In this video, I'm going to talk about how to evaluate cosine, sine, and tangent using our special right triangles and the unit circle and placing them in the unit circle. So, for example here, I've already drawn out my special right triangles with a hypotenuse of 1, our half square, and our half equilateral, and we're going to try to place them correctly in the unit circle depending on what this angle is. So the first thing I need to figure out is how do I draw where the 210 degree angle is. We always measure from the origin and from this positive x-axis going in a counterclockwise direction. So right here along the positive x-axis represents 0 degrees. Then we have 90 degrees. If we keep on going around counterclockwise, we've got 180, 270 degrees. Then we'd go back to 0 degrees after 360, so we could continue going around the circle. So the next thing I want to figure out is where does 210 degrees lie on this unit circle? And since 210 degrees lies between 180 and 270, I know that this point will be in the third quadrant because I'm measuring around and it's about 210 degrees. And now we're going to draw in the corresponding right triangle so that we can figure out what are the coordinates of this point right here in green. Because if I can find the coordinates of that point, then I will be able to determine cosine and sine. So we'll draw in this right triangle. Notice that the green line would represent the y-coordinate, and this would represent the x-coordinate of this point in green. And I want to figure out how much is left over, what this angle represents in that triangle. And since we've gone past 180, 30 degrees to get to 210, I know this angle is 30 degrees. Then I can label the rest of the triangle based off of what we know about special right triangles. Because it's a unit circle, the length of any radius from this, so that anything from the center of that circle to the circle itself has to be a length of 1. And that's why we've drawn these special right triangles above with a length of 1. I'm going to label the other sides in relationship to that. So if I look at my original special right triangle, across from the 30 degree angle, which is the smaller angle, is the shorter side of 1/2. So when I look at my triangle in the unit circle, across from the 30 degree angle would be 1/2. And then across from the 60 degree angle would be the square root of 3 over 2. Now that I've labeled it in this circle, I have enough information to find the coordinates for this point. Notice that from the origin, we've moved to the left along that square root of 3 over 2 leg, which means that's negative square root of 3 over 2. And then we've gone down 1/2, so that would be negative 1/2. And in the unit circle, we've defined that cosine represents the x-coordinate and sine represents the y-coordinate, which we derived on the first day. And then tangent is given by the ratio of y over x, or sine over cosine. So now that we've placed the points for the coordinates for that point, then I know that cosine of 210 degrees, which is the x-coordinate, would be negative square root of 3 over 2. Similarly, sine of 210 degrees would be the y-coordinate, which is negative 1/2. Now, tangent is the trickiest one because it requires some simplification often. But I remember that it's the ratio of y over x. So that's negative 1/2 over negative square root of 3 over 2. I notice I'm dividing a negative by a negative, so that becomes a positive. And then I also notice that in the denominators of both of the numerator and the denominator, we've got this 2. And so in order for me to simplify that a little bit more, I'm going to multiply by 2 over 2. It's just a form of 1. I haven't changed the value of what we're looking at, but it's just a way to simplify it a little bit more. So 1/2 times 2, well, it's multiplied by its reciprocal, so that's just 1. And then in the denominator, we have the square root of 3 over 2 times 2, which gives us the square root of 3. Uh-oh, we can't have a radical in the denominator, so we're going to simplify it even more by rationalizing. And to do that, we need to multiply by another radical. So we're going to multiply by the square root of 3 over the square root of 3. Again, this is just a form of 1. It's not affecting or changing the value of this amount. It's just rewriting it in a more familiar form. The numerators will multiply across, so we have 1 times the square root of 3. And then the denominator is the square root of 3 times the square root of 3 is 3. So our tangent value, notice in quadrant 3, is positive, and it's positive square root of 3 over 3.